What is massive IoT and how it differs from traditional IoT? We'll dive into the technologies powering massive IoT, network slicing and edge computing. Learn why these innovations are crucial and how the Solid B4G project could revolutionize industries like automotive and maritime. What are the potential impacts of deploying massive IoT networks on a large scale for our planet? Join us on Research in the Spotlight for an exciting episode uncovering the future of connectivity and its far-reaching implications for society and the environment. Don't miss it. What is massive IoT and how does it differ from the traditional IoT we are familiar with?
Massive IoT is a technology involving the connectivity of a very large number of devices and processing of their data. It differs from the traditional IoT since it involves a large amount of data and a huge number of devices. It can involve artificial intelligence, big data processing, and a small delay in terms of connectivity.
In what ways could the advancements from the Solid B5G project impact the automotive and the maritime industries?
So the worldwide maritime Internet of Things market is expected to experience a high growth rate, about 17% CAGR until 2030. So and this highlights the growing importance and potential of maritime IoT applications in the global market. As such, we believe that this is the right time for the project outcomes to be exploited. Technology providers and solution developers in the maritime industry can leverage the Solid B5G project to enhance their offerings for companies that specialize in maritime communication, in navigation, in IoT, or in vessel management systems. Also, shipping companies, port authorities, and maritime service providers stand to benefit from the Solid B5G project because it enables them to optimize the vessel operations and to reduce downtime and enhance the reliability of maritime services. For our company, the project has had a significant impact. It allowed us to slowly enter the market for maritime IoT and to further advance the maturity level of the developed components within the project. And this has happened both via new research and development projects, but also via commercial projects with maritime stakeholders.
What are network slicing and edge computing, and why are they important for the future of massive IoT?
So, network slicing is a technique that allows the creation of multiple virtual networks over a single shared physical infrastructure. The advantage is that each of these slices can be configured separately from the others in terms of security and performance. Edge computing, it's a different technique. The idea is to allow the migration of the cloud computing resources towards the edge of the network. The advantage of edge computing is that by doing so, it's possible to minimize the real-time latency because the processing can take place closer to the final user. Another advantage is that in this way we can have awareness of the physical environment. These two different techniques, network slicing and edge computing, can be combined, and by combining them in the context of massive IoT, we can have advantages regarding the optimization of both security aspects and performance aspects like reduced latency.
In this project were involved two partners from Norway, the University of Agder and Telenor Maritime. During this project, together with University of Agder, we collaborate writing good quality of journal papers with a high impact in our domain, and the Telenor Maritime company bring us the view from the industry part.
What are the potential social impacts of achieving ubiquitous connectivity with massive IoT at a density of 1 million devices per square kilometer?
When achieving ubiquitous connectivity at such a large scale of 1 million devices per square kilometer, we think about those scenarios, those use cases in which we have high demands from the point of view of resources. And such applications can be smart traffic light management system, cargo shipping. We have also environmental monitoring, or of course waste and cleaning management. So we have a very wide palette of applications that can impact not only a specific user, but also the entire society.
What are the environmental considerations and potential impacts of deploying massive IoT networks on such a large scale?
When we have a large-scale deployment of IoT devices, of course, we think about the consumption considerations. But we have to know that from the beginning, from the terminal point of view, IoT devices are very low power consuming, and also their battery lasts for several years. So from the beginning, such infrastructures are more efficient from the point of view of power management. And also, if we think about network deployment, we have large demands, but we can employ smart energy management techniques, such as those employed in 5G core power management.
What are some examples of the applications and benefits of massive IoT in everyday life?
In 2018, China International Maritime Containers introduced a new system for smart containers shipping, which can provide monitoring of the containers to the expeditor and also to the destinatory. A few years ago, such kind of systems involved data accessibility through several systems, locations. So the new system integrates a lot of new features in one single platform. In 2020, Walmart said it processed more than 1 billion of IoT messages through its supermarket monitoring systems. This is used for maintaining food in refrigerators and having an actual image of the supplying in the whole distribution stores.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the Norway Grants research program by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is a key to a better future.